10 to the minus 10 meters from the proton. What is, okay, so we have some calculations to do. Right, so let's draw the picture here. Electron orbits the proton, goes around. What is the electric field strength at the electron's location caused by the proton? So here's the proton, and the proton sends out an electric field, and I want to know how strong it is. So which formula do I need here?
Equal 1 over 4 pi e
Yeah.
epsilon z.
It's this one, isn't it?
Yeah. Q over r squared.
That one. Yeah, so let's calculate it. 1 over 4 pi, oops. What constant is epsilon 0?
2.
Was it 32? Good math. And then the charge is 23. And then squared. And that's the answer.
Yeah.
I'm actually going to store this answer. Guys, did I show you how to store answers on your calculator? No, I better show you that because it could be useful for you. So suppose you get an answer on your calculator and you want to save it somewhere so you don't have to type it all in again. These letters here, I think most people have it. You see like A, B, C, D, E, F?
Yeah.
You can use those letters to hold values. So I press Shift, Store, and then pick the letter I want. So hang on, let me just get it back up. So here I would press Shift, Store, and then I'll put in letter A.
Yeah.
Now watch, I can get the A back later, alpha A.
Did you store it forever?
Well, nothing is forever. For a long time.
Can I
Maybe a year or two.
more than 2 things? Like
Yeah, well, each letter can hold one value, but you can store it in different letters.
3, 4, 5, 6, 7, 8, 9. We can store 9 numbers.
Is it?
Right? Just like
Okay. Guys, continue. Can this calculator do it? It can. Wow. Which one do you have?
You look down on this calculator
What?
so much.
No. No. Right. B. The force experienced by the electron from the proton. Okay, so what's the formula for force?
Q.
EQ. And we already have it right there. There's the E, so I'll just multiply it by Q. 2.3 times 10 to the minus 8 newtons.
if I put negative 2.31, is it okay?
It's okay. Now, since this is answer B, I'm going to store this for B. Shift, store, B. Okay. What is the acceleration experienced by the electron? So Newton said F equals ma. So then A equals F over m. Now, I still have my answer for F, so I just need to divide it by the m, which is constant 3, isn't it? Yeah. So the acceleration is 2.53 times 10 to the 22. And let me store this as answer C. Okay. Now, what's the periodic time of the orbit of the electron? D. Yeah, so it's 2 pi over omega. But we can use our trick again, can't we? Because we can say, remember, F, because it's moving in a circle, F equals m omega squared r. Yeah? So we can say that this is 2 pi, what did we get last time we did this? Root m r over f.
F equals EQ, yeah.
Well, no, I don't even have to do f equals eq. Why not?
Because we know the F.
It's answer C. So it's 2, B is it 2 pi root m or over f, which
B.
I've stored now conveniently into B. So now I can get this 3. That's really small.
Yeah.
3. No, that seems too small. Did I forget something?
No, I got the same thing.
We got the same? Oh, then I must be right. 3.95 10 to the minus 16. Whoa. Okay. Next now. What's the next one? E. Now, this is interesting. What is the electric field strength caused by the proton's location? Caused at the proton's location. The strength at the proton's location caused by the electron. So, if you are the proton, you will feel a field from E, the electron, and it will be going. It'll feel like it's going like this. I have to do it in blue. So the electron has a field and it's pulling you in as well. And the question is, how strong is this? Well, it's the same formula, isn't it? E equals 1 over 4 pi epsilon 0 q over r squared. And you realize if you put the numbers in, you actually get the same as A, because all the numbers are the same. And the F,
Same.
you get F equals EQ. And again, you realize the E and the Q are the same, so in fact this is the same as B. Yeah. G,
Nothing.
not the same,
Yeah.
because A equals F over M, and this is where it's different, because the M is now different. So, F over M.
F equals B.
Yeah?
Must be.
Huh? I thought the F was B. Wasn't it?
B.
F equals B. Yeah.
1.379 times 10 to the 19 meters per second squared. Now notice how that's 1,000 times smaller if you were to compare it with the answer you got. C, was it? Yeah. That's 1,000 times smaller. So what does this mean? It means if you were to look at the proton and the electron, the acceleration here is 1,000 times bigger than here. That's why the electron moves around the proton and not the other way around. There is a force on both. The force on the electron is making it move in a circle, right? But what's the force on the proton making it do? See, we haven't really thought about that, but it's going to have some effect. So what is the effect? What do we think? Yeah, but, I mean, how will the proton move?
Okay.
No, because we said only the electron is moving in the circle.
Left and right.
Yeah, what's this called?
Left and right.
You know what
Vibration.
you know what this is called. Simple harmonic motion.
Yeah.
So this will be vibrating as this one is rotating. Why not? Yeah, why is it vibrating? Well, what else could it do? So, could it move in a straight line? Well, huh?
It moves like move in a circle, like in its own orbit. Like
Yes. Yeah, you see, this is the thing. It is moving in a small circular orbit. But because the orbit is so small, it appears as if it's just vibrating. But you're right, like if you were to really, really, really like look at it, zoom in on it, it would be kind of sitting there going around in its own little orbit. But when you are at a scale that's 1,000 times zoomed out and you're looking at the electron going around it, it appears to be just vibrating. And you can actually, you're allowed to assume here that its motion is simple harmonic. And in fact, they do something similar to this. They assume it's simple harmonic motion when they're doing sort of analysis. You see something like this as well with planets. This is what you were thinking of, perhaps? The Earth going around the Sun. We picture the Sun as being fixed, but actually the Sun is also moving in a little orbit. It is, yeah. Here's the Sun here, and here's the Earth, and we picture it going around like this, and this is fixed. In fact, the Sun is going around in a little orbit as well, and the point is actually somewhere about here on the edge of its circumference. So the Sun isn't quite, it's not quite stationary. But we can imagine it as just vibrating left and right, back and forth as the planets orbited. Okay, so that was kind of hard for question 1. Let's have a look at question 2 now.
the two particles never
Say again?
the two particles never
In real life or in this model?
both.
Okay. In this model, no. This continues forever. In real life, what we'll discover later in the semester is the electron, its orbit can jump. So it can, like, I guess you could say, decay, or the electron could escape or something like this. We imagine it's stable, whereas really it's not stable forever. Yeah.
Even though they're pulling each other, they never.
Even though they're pulling at each other, it's still stable. And the reason it collapses is not because it's unstable here. It actually is stable. The reason it collapses is due to our friend quantum mechanics. Okay. Number 2? Number 2, I can go down, yeah? Okay, so the second one. 2 horizontal plates are held a distance of 10 centimeters apart, under a voltage of 1,000 volts. What charge would you need on a gram so it does not accelerate? So in other words, I want to put a gram here, is it? Yeah, and I want it just to float there. So let's just call this plate positive and this one negative. So firstly, do I need a negative or a positive charge?
Negative.
Negative charge.
Yeah.
Yeah. And I would need the force that's pulling it up, the field, to cancel the weight, exactly cancel it.
Yeah.
Okay, so we need EQ equals mg. Oh, I think I made this too easy. No, I know I made this too easy, because it's just mg over E. And what did we say E was for these types of problems?
V over D.
V over D. Voltage over the D. So here we get 0.001 times 9.81, and then we have 1,000 over 0.10. So it needs to be 9.81 times 10 to the minus 7. coulombs. Yeah, or 981 nanocoulombs.
How did you know if you won the, how did you
Ah,
know?
no, it's irrelevant. If you draw it the other way around, that's fine. It's, yeah.
Can I
In
see-
fact, technically, it's minus because I said at the start I wanted a negative charge.
Can I see the calculator?
Calculator. Yeah.
What if it's a positive charge? And then it gets subtracted to,
Yeah. Well, if this is a positive charge, you would need the negative plate on the top. Yeah.
Why did we use BBL?
That's one of the formulas we did in the class, that when you have parallel plates, the field strength between the plates is the voltage over the distance. Is this okay, guys? This one?
what does it mean by the last sentence will not accelerate between the plates?
Oh yeah, so like it appears to float, or at least move at a constant speed. Well, same thing. I could have done it so that it's positive. The charge is really not important. Like I never actually said, oh no I did actually, the positive plate above the negative. Yeah, so it needs to be negative because like an electron has to be pulled upwards to cancel the gravity. Because the gravity is pulling it down. Okay. Got that? Yeah. Next question? Oh, God. Okay. Number 3. Two vertical plates are held a distance. Let's try that again. Two vertical plates are held a distance which is 30 centimeters. They're 10 meters long. Some dusty smoke of mass 10 minus 5 kilogram rises at a constant half a meter per second. So you have some dust coming up here, and the mass is 10 minus 5 kilograms, and the speed this dust is moving up at is, I'll call it V, is 0.5 meters per second. And it also has a small charge, which is 10 to the minus 10 per dust particle as well. Now, this actually happens in real life. When you see those factories, you'll probably notice sometimes that these factories have really tall chimney stacks. Yeah? And there's two reasons for it. You want to get the smoke away from ground level, but also what you sometimes have is an electric field between the plates. Because the dust or the dirt sometimes has a positive charge. So what you can do is you can pull the dirt out of the smoke and have it stick to the wall. And then at the end of the day you can hit the wall and get all the dirt and collect it up. So this is good. It makes the city a little bit cleaner because the smoke isn't so dirty and sticky. You pull some of the sticky, dirty stuff from the smoke. So the question I ask you is, how much voltage do we need in order to catch all the smoke, all the dirt out of the smoke? Yeah? So do you understand the sort of the idea of what we're trying to do? We're trying to get the dirt out of the smoke, okay? So I'll call this plate, this one I'll call, what did I say it was? 10 to the minus 10. I'll call this one positive and this one negative. And let me just remove the smoke. Okay. So, we need to consider the worst case, alright? Well, let's consider the best case. The best case is the smoke comes out on the right. And because it's positive, it will quickly stick to the wall, because the wall here is negative. But what's the worst case? The smoke comes out on the left. Oh no, actually the left would be worse, because it has to get pushed away from the wall and then make its way all the way over to the right. Yeah? Huh?
Door.
True, true.
Oh.
But
How do we
that
know?
doesn't help it enough. Yeah.
Oh, yeah.
Because it's very, like, it's very gentle repellent, yeah. So the worst case is the smoke is here, and it slowly gets pulled to the right, and we just about get it before it's too late. That's the worst case we have to consider. Oh, before I continue, I should actually say this was an exam question. That's why I actually have it here. Yes.
Any question?
Yes, that's why I put it in.
Oh,
Yeah. Well, that's why I want you to listen carefully, okay? Now, question 1 to you. How much time do we have to catch the dirt? What's our time limit here? Could we work it out?
Long time.
Well, not that long.
Quite long.
Well, how long?
I don't know.
I think you can. No. How long is the chimney? 10 meters. How quickly is the smoke rising vertically? 0.5. It's moving at a constant 0.5 up the chimney, I said. So how long do I have? I have 20 seconds. Okay, great. 20 seconds.
Why did you put delta M and delta Q?
I just wanted to emphasize that it's small and it's per particle. I don't need to. Time is 20 seconds. Good. So what do we need to try and do in that 20 seconds? We want to try to get the particle from the left to the right. Simple. Okay. So let's look in the x-axis. X-axis. So we're looking this direction, all right? U, V, A, T, S. The U,
Zero.
now, yeah, what would be the worst case? 0
Yeah.
would be the worst case, because actually if the U wasn't 0, if it was already moving, it would actually help us. The V, we don't know. The A, we don't know. The T,
20.
we do know. 20. And the S,
10.
10. So could we know the A?
Yeah.
We could. What formula? Let's see.
S equal UT.
Yeah. S equals UT plus a half A T squared, isn't it? So that's 200A. So 1 over 20, I think, is the A. So the A is 0.05, 1 over 20. Okay, but that doesn't tell me what the voltage is. So how can I go from this now to working out the voltage I need? Well, if I know the A, what else could I know? Yeah, using what?
F equal ma.
Yeah, well, because Newton said F equals ma, I can get the F is 10 to the minus 5 times 0.05.
5 by 10 to the minus.
Whoa. I trust you mostly. 5 times 10 to the minus 7, as you said. Okay, but so what? I have the F. How does this give me the voltage? Well, what can I say the F equals using one of our formulas? You could say it's equal to EQ.
Yeah.
Oh, well, I know the Q, don't I? So if I divide by Q, I can get the E. Okay, well, so now I have the E. So it's going to be this divided by 10 to the power of minus 10. So that's 5,000. Fine, I have the E, but I still don't have the voltage. But then I remember I have the formula E equals V over D. So then that means D equals, sorry. Huh?
No. V over D.
That's right, isn't it?
Yeah.
Yeah, and I have the E,
Yeah.
and I want the V. So V equals ED. And the D is, what did I say? How wide is it? I forget now. 10 centimeters, isn't it?
Yeah.
10, or 30 centimeters, sorry. So if I multiply this by 30, oh wait, so this is wrong here. We said, but nobody corrected me then. This is not, you students. Now look at this now, disgraceful. Look at this disgrace, because the S here is not 10. Yeah, but x-axis. Oh, what a disgrace. Oh.
Okay. We got the idea. That's enough. That's enough.
Yeah, well, let's go through it again quickly. So the S here is 0.30. So S equals ut plus a half a t squared. So the A is 0.3 times 2. Right. 1.5 times 10 to the minus 3. Okay, let's try and do this in one step to save time. So Newton said F equals ma. Yes? But we know that F is equal to EQ. But we know that E is equal to V over D. So therefore, V is equal to MAD over Q. Okay. What's the M here? 10 to the minus 10, isn't it? The A, I just worked it out. The D, 30. And the Q is 10 to the minus 10.
No.
No?
The sign. Yeah.
What happened?
No, there. What divide? You have to divide that point. Why are you doing that?
Hang on, let me think. I don't know what's going on.
You can see that. The problem.
Can I?
Yeah, 0.30. Yeah.
There. That's wrong. Because my... No. Oh, I know what it is. Sorry. I need a bracket here. Sorry. M.
It's wrong.
10 to the minus 5. A. 1.5 times 10 to the minus 3. D. 0.30. Q. 10 to the minus 10. Answer 45. There we go.
Because you first time you put the mass is.
Yeah, I know. 45 volts is the answer here. Okay. Yeah, it's a little tricky when I saw it. It was a section B question a while ago. They're not usually that hard in the exam, but I thought it was an interesting example. Did anybody actually get it themselves? 45 volts.
I thought that the particle, the dust, had some weight. You know the.
It does. But when
we couldn't consider that.
Yeah, but when I said the particle rises at half a meter per second, that's considering its weight and the up force caused by the heat of the smoke. Okay, did you write that down? Is there another what did we do last class?
This
It was this one, so we're on to a new topic?
yeah.
Yep, okay. Can I close this?